A very warm welcome to each of you as we gather here today. And it is nice to have participants that spans not only from Southeast Asia, but also from Asia's countries and across the world. It is truly an honor to stand as your master of ceremony on this occasion. Okay, to begin with, I would like to present about the agenda for today. So we will have 1.5 hour session today. To begin with the introduction to the program itself by Satya Budi Utama as project manager. And then we continue to the presentation of the topic, highlight of the air pollution episode by Beatrice Cardenas, our air quality director. And we go into the main session, talking about the high air pollution episode, understanding through data and tools. This will be presented by Rajesh. And we have a 10 minutes Q&A session. And we continue to the panel of cities representative here. And we already have a Manila city representative and Jakarta city representatives. And we have the second Q&A session before we close our session. Without any further ado, this is the rules of the Zoom session in this session. So please be kindly informed that this webinar will be recorded for documentation purposes. And you are encouraged to utilize the chat box for interactive discussion and networking during the session. And to ask the questions, we kindly request that you use the Q&A feature on Zoom. And this allows us to address inquiries effectively during limited time of Q&A session. And during the session, I would like to invite you to sit back, focus, and derive maximum value from the insightful content we have prepared for you today. And should you require any assistance or encounter technical issue, please do not hesitate to contact our support team. My email is here to support you if there is any technical or assistance required. So we also provide interpretation for Bahasa Indonesia and English available on the Zoom. The further instruction is provided in chat box, and you can stay on English or Indonesian channel. Okay, to begin with, I would like to invite Satya Budi Utama or Tommy. He is a project manager for air quality in WR Indonesia. Satya or Tommy serves as the project manager, and previously he led WR Indonesia in sustainable use of peatland project under EU delegation from 2020 to 2023. In this role, he provided programmatic leadership for air quality, overseeing the development, implementation, monitoring, and evaluation project. Tommy brings extensive experience in program management, particularly in disaster reduction and climate change adaptation. So I would like to give the stage to you, Mas Tommy, to introduce the program of Southeast Asia Quality Community Practice. The stage is yours, Mas.
Thank you very much, Fadil, for the introduction. And I wish to extend a warm welcome to our participants joining from Jakarta and other cities in Southeast Asia, and also to the other participants joining from the other side of the time zone. So a warm welcome for our first session in Southeast Asia Air Quality Community of Practice. So before coming into our main menu for today, allow me to introduce a bit about the program that we have. I hope everyone can see my screen now. So again, welcome to the first session of Southeast Asia Community of Practice. Our today's topic is high air pollution episode in cities, understanding through data and tools. So let us begin with a quick fact about the condition of the air pollution in Southeast Asia at the moment. So the air pollution has becoming a prominent topics of discussion in Southeast Asia, not only among the scientific communities, but also at the communities of the citizens at large. So we have a bit of unfortunate facts about the current condition in Southeast Asia, sorry. So the air pollution cut short the life expectancy of the average Southeast Asian person by 1.5 years. And unfortunately, there is also the fact that out of 10 people now breathe polluted air in Southeast Asia. A bit of a good progress is that 7 out of 11 countries in the region are now moving towards best practices in air quality management. So I hope what we are doing now is also contributing to the establishment of best practices in air quality management in this region. The Southeast Asia Air Quality Community of Practice was launched in Bangkok in June 2023. That coincides with also the event on the Climate and Clean Air Conference 2023. It was organized in Bangkok. So the aims of the establishment of the community is to connect the air quality practitioners and also the academics and the wide range of stakeholders at both the city and the national levels in Southeast Asia. So through this initiative, we hope that we could encourage participations from the stakeholders in capacity building activities and also to establish a joint platform for sharing of our experience in addressing the air pollution issues in this region. So at the time of the launch of the initiative, there were also 32 attendees coming from the 8 cities in Southeast Asia. So we had people coming from Jakarta, Denpasar from Indonesia, Kuala Lumpur, Putrajaya of Malaysia, and also people coming from Hanoi, Vietnam, and Manila, Bataan, and Quezon City of the Philippines. So this is a bit of snapshot of the location of the work at the moment. So currently we have stakeholders connecting with the community from Indonesia, Malaysia, and Philippines. And we also hope to expand to the other countries in Southeast Asia. The project is supported by the US Department of State and led by the World Resources Institute. We are aiming to establish a sustained cross-border experience sharing through these sessions. And hopefully, we can also overcome the challenge and gaps in understanding the air quality challenges in this region. So a bit of the overview of activities under the Southeast Asia Air Quality Communities. We are now in the first year of the project at the stage of assessing the needs and priorities at the city level and also at the country and regional level. Our activities in the first year started with the launching or hosting the inaugural meeting of Air Climate and Clean Air Conference in Bangkok. It is also marked the launch of the communities of practice in Southeast Asia. We foresee in year 2, we will establish a sustainable experience sharing platform for air quality. So we'll have a more robust platform, hopefully by next year, on sharing the experience from the practitioners. And in year 3, we will continue with our policy masterclass and science shadow fellows for air quality practitioners. Through these activities, we plan to secure the outcomes of strengthening the knowledge and technical capacity in monitoring, modeling, and other air quality management tools. And also we have another outcome to foster cross-border experience sharing on best practices on clean air action planning. So in coming to our first sessions today, we also conducted assessment surveys on the challenges and capacity needs support for the cities. So as you can see, the snapshot of the surveys shows that there is a prominent challenge in terms of the lack of monitoring and assessment. And also there is a challenge related with the policy gaps in air quality management. And with that, there is also a priority list of capacity need support submitted by the stakeholders. At the top, we have the needs on the capacity support related with the policy and clear air action solution formulation. We have also quite a long list of capacity building topics that is interesting from our practitioners and stakeholders, ranging from the formulations of clean air actions through the air quality forecasting for series. So hopefully throughout the years of the implementations of this project, we will be able to cover all of these topics that are put forward by the stakeholders and practitioners in the communities. And we had also a list of potential topics for next sessions. They are related with data and tools on the air quality data, the air quality indicator, and as well as the monitoring network. And hopefully will be able to share our best practices from different series on the participatory science, climate, waste, and clean air, on transboundary air pollution, air quality and equity, as well as the transport and urban development initiative to achieve clean air in our region. So that's a bit of what we are aiming to do within the framework of the Southeast Asia Air Quality Community of Practice. So this is the link for you if you are interested also to join the community. You can scan the code, and also you have the link to join the community of practice. This will also be shared after the conclusion of our sessions today. So hopefully we'll be having more people joining the Southeast Asia Air Quality Community of Practice. Thank you. With that, I pass it back to Fadil. Thank you, Fadil.
Thank you, Mas Tommy, for explaining us about the programmatic for Southeast Asia Air Quality Community of Practice. So today we are happy to announce that there are 46 attendees joining this session, ranging from Indonesians, Malaysian, Philippines, and other countries that I cannot mention one by one. Thank you so much for joining us. And please, you can use chat box to interact between each other, and later to give the question in Q&A box. For the next sessions, I would like to invite Beatriz Cardenas to present the overview of high air pollution episodes. Why would we raise these topics, and what is actually air pollution episodes? Beatriz Cardenas is our air quality director from World Resources Institute Mexico, and she also leads the global air quality team at WR Global, and she's expertise in air pollution with a background encompassing both scientific research and policy development. Without any further ado, I give the stage to you, Beatrice, to present about the highlight of air pollution episode. Stage is yours.
Thank you. I will be sharing my screen. Can you see it now? Okay.
Yes.
Well, it's I will not take more time. I think that we are all eager to hear about what are the tools, the data that air pollution events can, how can we use them, and also listen from two air quality practitioners or experts what their experiences in their cities. I would just like to share with you, I mean, among the topics that we have identified that are important of interest of the participants, these high pollution events are unfortunately more frequent than we would like to. They are happening everywhere. And yes, unfortunately, they are more frequently in cities in the global south. So one of the questions that we would like to answer today, or at least just to present and trigger for you to think about it, is that, so I'm thinking about since when we are suffering high pollution events, and maybe we have been suffering for a long time, but until we have some tools and data to monitor and to share what's going on, is then when we are not only experiencing these high pollution events, but we are trying to do something. So we can define a high pollution event based on what are the metrics that we are using. But what we can say is that when we are reaching high levels of air pollutants that are damaging the health of people and ecosystems, we are definitely experiencing high pollution days. What pollutants that also change from place to place based on the conditions and based on the sources. And I think that one of the questions that frequently is being asked to policymakers and air quality managers is why this high pollution event happens. What are the reasons? And that's something that we will also discuss today and would listen from the experts. And I think that one of the best, the most frequent question also is, what can we do when we have these high pollution events? Can we do something either to know when they are coming so we can take some actions, or what can we do to reduce them in the short, mid, and eventually in the long term? And yes, we all know about the high pollution event, the famous high pollution event that happens in 1952 in London, all that triggered, all the data that was collected and what actions were taken after that. The other well-known case is Mexico City. In the 1980s, it was identified as the most polluted city in the world. What you can see in the graphic here is a mosaic of the high pollution events that had happened over the last 3 decades. If we use the level as a purple, as a very high pollution event, very high levels of air pollution, we will have this mosaic. So that means that in the 1980s, in the 1990s, we have most of the year of high pollution events that we now consider a high pollution events. That means that as soon as we have data and as soon as we define what actions are going to be taken and what are the levels that we definitely consider as a high pollution events, then we take actions, and then eventually these high levels are decreasing. Still, there is a lot of work. If you see the last row, when you see the square in red, that means that there are also high pollution events. This is for ozone. It's the highest concentration in 1 hour in Mexico City. That's one of the metrics that is considered to determine we have a high pollution event right now, and then a lot of actions are being implemented. But if you see, so over the time, there has been some progress. We don't have many purple squares, but still Mexico City is experiencing high pollution event, less, but still. And just a couple of examples in 2016, in 2019, and even last year, there were also high pollution events. So that's a problem. There is some progress, there are some actions, and we all can share the actions. We can all share what tools and data can we use, not only to forecast them, but also to make some actions to reduce them. And yes, high pollution days are not only in the news. If you look where to go as a vacation, you can even find in TripAdvisor some information about high pollution events, how the pollution is. This is just an example how air pollution is in Mexico. So that means that people are more conscious. So we are hoping that there is more demand for clean air days. So all of us who are looking to have and implement actions to reduce these high pollution days event are effective. And yes, we can learn from previous experiences. You may have seen that even these high pollution events in London have been even included in one of the on the Netflix series that happened that was broadcasting. So that means that we have more knowledge. This is a demand, and we can do a lot, not only to understand, to explain to others, but most importantly, to implement action to improve the air. So that's it. That's the whole idea why we would like to start discussing. Thank you so much for all the experts that will be sharing today their knowledge, their experiences, and maybe have some ideas on how can this be, how the air we breathe could be improved. Thank you.
Thank you so much, Beatrice, for giving us an overview on why we take this air pollution episode or air pollution event within this topic. And as we understand currently that overall in Southeast Asia region that we are facing the dry season in which that might affect the pollution concentration or pollution level in the atmosphere. Okay, thank you for the opening session. So this is we are going to the main stage, and before I give the stage to our main speaker or the our main expert here, I would like to give further guidance to Aska Gaida, who will be our moderator. Hello, Aska, are you there? Hello, Aska, can you hear me? Hello, Aska, I cannot hear you. Mas Tommy, can you hear Aska or is this only me?
No, I think you can just go ahead first, Fadil. Maybe Aska is having a bit of a challenge with the connection.
Okay, sure. Perhaps we can continue to our main speaker. I would like to introduce to Rajesh Kumar. Rajesh, are you here? Thank you so much for participating in this community of practice, and thank you because there I believe it's evening already, and thank you for allocating the time for us. Rajesh Kumar is the interim deputy director for Research Application Laboratory, National Center for Atmospheric Research or NCAR. Rajesh is a project scientist and also co-chair of the International MAP-AQ program associated with WFO and ICGAC. His research focused on air quality, a critical global concern responsible about 7 million premature deaths. We already know that. And he already authored 83 peer-reviewed publications and secured 44 USD million in external funding for his work. Rajesh, without any further ado, I would like to give the stage to you to present the air pollution episode and understanding through the air rules.
Yeah, thanks a lot, Fadil. Can you hear me okay?
Yes, I can hear you very well.
All right, so let me share my screen. Is the presentation available, is visible in the full screen mode?
Yes.
Okay. All right, so yeah, thank you very much for the opportunity, and thanks to Tommy and Beatrice for setting the stage for my presentation. Since this Southeast Asia community of practice really focuses on high pollution event, I decided to talk about the air quality in Delhi. We all know that New Delhi is one of the global hotspots for air pollution. And in the recent years, air quality has deteriorated to such dangerous levels that it required emergent attention from the governments. And there have been a lot of things that have been done in New Delhi over the past 5 or 6 years. So I'm going to talk about how we have been contributing to enhancing air quality decision-making activity in Delhi by integrating air quality models with multi-platform observations. So you can see here we have a long list of people who are all contributing to this air quality early warning system that I'm going to talk about in today's talk. And these come from a lot of different institutions, including NCAR, which is sponsored by the National Science Foundation of the US, the Indian Institute of Tropical Meteorology, Indian Meteorological Department, as well as the Central Pollution Control Board. So, very brief outline of my talk. I'm gonna provide you a brief overview of air quality problem in Delhi, one slide on government's initiatives to tackle the air quality problem, and then the development of the air quality early warning system, and conclude with a summary slide. So for people who do not know where Delhi is, it is located in northern part of India. It has a population of just over 30 million people, with a very high population density of 20,000 people per kilometer square. On the right here, you can see the population density map. So the Yamuna River flows through the eastern part of Delhi, and you can see that there are neighborhoods with very high population density. So these people are engaged into a lot of human activities which lead to emissions, like any other city. And these emissions contribute to the air pollution problem in Delhi. So what are really the emission sources that affect Delhi? So here on the left, do you see my mouse, Fadil, as I'm talking?
I cannot. Oh yeah, I can see.
You see
Small
it? Okay.
pointer, yeah.
Yeah. I'm not sure if I can use a. Anyway, so on the left side here, you see the anthropogenic emissions, which are resulting from all the people living in Delhi. And these are one of the sources which affect air quality in Delhi throughout the whole year. Then another source, which is very seasonal and appears during spring and fall, is related to the crop residue burning. And this crop residue burning mostly occurs in upwind states of New Delhi, which are Haryana and Punjab. And you see, this is only 1 day fire count. You also see some smoke resulting from these fires, which then travels to New Delhi. So in addition to the local emissions, emissions from outside of New Delhi also affect air pollution in Delhi. And then there are dust storms on top of it, which mostly occur during the spring season. So how do the ozone and PM 2.5, which are two criteria pollutants, how do they vary seasonally in Delhi? So here you see a seasonal cycle of PM 2.5 in Delhi. This is a multi-year time series going from January 2012 to December 2014. But you see that year after year during the winter time, PM 2.5 pollution is very high. The PM 2.5 average, monthly average concentrations are going up to 250 to 300 micrograms per meter cube, with the peak values going to 500 micrograms per meter cube, and sometimes even reaching the levels up to 1,000 micrograms per meter cube. So it's a very, very serious situation. But during the summertime, as you can see here, during the summertime, PM 2.5 pollution is very low. But when you look at ozone, during the winter time, when we have the PM pollution problem, we do not have the ozone problem. So the ozone problem is really during April, May, which is when we have the highest solar radiation. So depending on the season, you have different type of pollution problems in Delhi. So what has the government been doing? The government has taken a lot of initiative, and I'm going to highlight those initiatives in this slide. So first of all, they have developed an air quality monitoring network, which includes about 50 reference grade monitors within Delhi. Then the government has funded the development of an air quality forecasting system, and most of my talk today is going to focus on that part. There is information dissemination. If you go in Delhi, you will find digital boards like this. You can get information about air quality through SMS, mobile apps, and websites. And then the government has also launched a national clean air program, which aims to reduce PM 2.5 by 20 to 30%. All right, so now the rest of the talk I'll focus on the air quality forecasting system. We use the WRF-CAM model for our air quality forecasting system. We are implementing WRF-CAM into a 3-domain configuration, where the outermost domain actually now covers entire India at 10-kilometer resolution. In fact, it also includes Pakistan, Afghanistan, Nepal, Bangladesh, and Sri Lanka. Then we have a 2-kilometer domain, which is focused on Delhi and the surrounding states. and a 400-meter resolution domain, which focuses simply on Delhi. All right, so, but is the WRF-Chem the best model to forecast air quality in Delhi? And so we started working on that and evaluating it. So in this slide, what I'm showing is a frequency distribution of the aerosol optical depth as seen by MODIS satellite in the blue color. And our WRF-Chem prediction, the default WRF-Chem that you can just download from the web and run it, we get the WRF-Chem prediction in red. So you can see that compared to blue, the red is substantially underestimating aerosol optical depth. And so I will show in the next slide that this run, the red color in this run, we also substantially underestimated PM2.5. So we decided, like, can we use satellite data to constrain aerosols into the WRF-Chem model? And then we assimilate MODIS AOD into WRF-Chem. And then you see the blue color is WRF-Chem with the MODIS AOD assimilation. Black is the MODIS actual original retrievals. And so you can see that now with the assimilation, we are forcing the model to see what the MODIS satellite sees. But what is the impact of this assimilation on surface PM2.5 concentrations and in terms of forecast? We are doing a 72-hour forecast in New Delhi. And so here I broke down that forecast into 3 different panels. So this panel here is showing the daily average values based on the first day forecast. This is second day forecast, and this is third day forecast. And this is the reduction in mean bias because of the assimilation of satellite data, MODIS AOD, into the WRF-Chem model. So you can see that on the first day, we reduced the mean bias by 86%, on second day by 81%, and on the third day by 70%. But what is very interesting is here, the black color is the observations. And these come from 24 sites that CPCB has installed in Delhi. And red is the WRF-Chem prediction without the assimilation of MODIS AOD. So you can see there is a large difference between the red line and the black line, which is telling us the bias in the default WRF-Chem model. Then we assimilate MODIS AOD, and now we have the blue line with the solid triangles. And you can see that it was able to substantially reduce bias. Means for the most part, except this peak here, which was related to the Diwali festival, there was large reduction in error. So even during the most acute air pollution episode that happened during this period, we were able to improve PM2.5 predictions by up to 200 micrograms per meter cube, which was a huge improvement. And all these improvements are not just resulting from the assimilation of AOD, but some of these improvements are also resulting from the interactions between aerosols and radiation in the model. So you can see if we assimilate the MODIS AOD, but we do not let aerosols affect the radiation, then we get the forecast in green line. And so the difference between the green and blue line is actually because of the interactions between the chemistry and radiation. So it is not only improvement to integrate information from various sources, it is also important to represent physical processes appropriately in the model. All right. So what we are doing with this forecast system has been running since October 2018. And Indian Institute of Tropical Meteorology had set up a website. It is called Air Quality Early Warning System for Delhi. And you can go on this website. I have included the link at the bottom of this slide. And you can find 72-hour air quality forecast along with near real-time evaluation and air quality bulletin and a lot of other information about air quality in Delhi every day. So this website has been visited by more than 200,000 people since it was launched. All right, so we had some success with the assimilation of the satellite retrievals, but as you might have noticed in the previous slide, we go from red to blue, but there is still a large gap between blue and black. And so with these initial developments of integrating information from satellite data sets and models, we were able to at least predict whether an air pollution episode is coming or not, but we were not able to reproduce the magnitude of air pollution. And so that's why we decided like, okay, maybe at 10-kilometer resolution, we are not representing the emission sources well enough into our models. And so we decided to go down to 400-meter resolution, which is very fine resolution going down to the neighborhood scale. But there are challenges of going down to that resolution. So first of all, we need high resolution emissions. So IITM, the Indian Institute of Tropical Meteorology, they actually developed an emission inventory at 400-meter resolution. But then through various sensitivity runs, we found out that the original emissions in that inventory were too high and did not take into account some of the policies implemented by the government. And so we ended up reducing the original emissions by about 40%. The second was constraining the model's initial state with the observations. So far we had only been assimilating the satellite data into the model, but there are also a lot of ground monitors. And in terms of air quality forecasting, our main objective is to provide as accurate forecast as possible. So we decided to assimilate the ground-based observations, but the data assimilation systems that have been developed in the US, they assumed PM 2.5 rarely goes above 150 micrograms per meter cube. So our first tests of the assimilation of ground-based observations were not successful. And then we went into the system and increased that limit to 1,000 micrograms per meter cube so that we can represent those frequent high pollution events into our data assimilation system. And then the final challenge we had was the model runtime. 400-meter run is very, very expensive. It takes about 8 hours to produce a 72-hour forecast on a big supercomputer. And so we had to come up with strategies where we are running the 10-kilometer and 2-kilometer domain together, and then so that those can be used as initial guidance by the decision makers and then do the 400-meter forecast later. So did it help? The question is, did the 400-meter resolution help? And so here I'm showing an evaluation during 2019 from 20 October to 1st February 2020. And in this figure, again, the observations are in black. Our 10-kilometer forecast based on the global EDGAR emission inventory is in green. So you can see that the behavior that we saw in 2017 persisted in 2020, where we were able to kind of predict up and down in the green line corresponding to the black line, but we never really made it to the observed magnitude. Then our forecast at 400-meter resolution, which is in red, now you can see that except few events like these two, all these events during from November to February, all these events were very well captured by the red line. So the reason is that here we are not able to capture it because during this part, we get a lot of influence from the crop residue burning. And so the biomass burning emissions are really uncertain. And so this error is in part related to the crop residue burning, uncertainties in the crop residue burning emission inventory. While during this part, things are controlled more by anthropogenic emissions. And with the 400-meter emission inventory, we were able to represent these peaks very well. Now, the next question was like, okay, we have the 400-meter emissions. Now, if we upscale those to 10-kilometer, do we still get the same accuracy? And we were able to get the same accuracy, at least on the Delhi average scale. There were large differences at the neighborhood scale. But overall, at the Delhi scale, when we upscale our emissions from 400-meter resolution to 10-kilometer, that forecast can be actually used as an initial guidance by decision makers. All right. So air quality forecast is a forecast. You know whether an air pollution event is coming or it is not coming. But how do you really make sure that if an air pollution event is coming, what type of actions I can take? So decision makers, they need source attribution information to make those type of decisions. So in Delhi, the Commission for Air Quality Management is a Supreme Court appointed body, which has come up with a graded response action plan. So depending on the level of PM 2.5, they activate different temporary emission mitigation measures. And for that, they need accurate forecast, and they also need to know from where these emission sources are located. So to help the decision makers, our next step was to develop a decision support system. And so we implemented 470 tracers into WRF-Chem so that we can track the major species, which is black carbon, organic carbon, and P2O5 in Delhi. And we want to capture different geographical regions. So this is Delhi and all the districts that are around Delhi, all the emission sectors of Delhi, including transport, industry, energy, waste burning, residential, construction, road dust, others, and biomass burning, and different emission scenarios. Like, okay, if you have an air pollution event and you want to reduce the emissions by 20% or 40%, how much improvement you can get in air quality. So all this information is obtained into a single WRF-Chem run. We do not do an ensemble here. We do this based on a tracer approach. And I'll be happy to talk to anyone who is interested in learning more about this approach. So what type of information this decision support system is generating? So here I'm going to play an animation. And so this is like the percentage contribution of Delhi and all the sources that are around Delhi, all the geographical regions to PM2.5 in Delhi. So this is a movie that will play. This is from 2021, and you will see the colors changing. So you see at this time, which is 10 UTC, that corresponds to 3:30 p.m. in Delhi. And you see that Delhi is the largest contribution to its PM2.5 pollution, but there is significant amount of contribution coming from other regions located south of Delhi. So I'm now playing the video. As we go into the night, the contribution from the Delhi local emissions increase because we have a more shallow boundary layer. Then we get into the daytime. Now the contribution of local emissions decrease, and you still get a lot of contribution from the southern districts that are located south of Delhi. Sometimes the flow changes, and at this time now you get more contribution from the northeast sector. So we produce this type of information every day. But this map is very confusing because the sources keep jumping around, and it is not very useful for the decision makers. So what we do then next is we actually provide time series information like this, where we have each geographical region represented. So even though the contribution from different sources are changing in time, you can see that, okay, the blue and light green, these are the two most important emission sources contributing to PM2.5 pollution in Delhi. And these are the two sources that I need to target as a decision maker. Then, okay, so the most important contribution is coming from Delhi, but which sector of Delhi? So we are producing that information here. We're at different emission sectors from Delhi. And from this diagram, it is clear that it is the energy, it is the industries and the transport sector, which are the main contributor to air pollution even during this forecast cycle. So this helps decision makers pinpoint the information like, okay, these are the sectors that I need to control. So what do we do with this information? We produce this information, put it on our website. The Commission for Air Quality Management looks at it, and if the air is predicted to be polluted, they restrict activities. And this is just a snapshot from the Indian Express, which is a leading newspaper in India, where it says NCR, schools, colleges shut construction at a halt till November 21st. And then when there is a prediction of a cleaner air, then they go back to normal operations. And that is also covered in media, which says schools reopen after pollution break. But the construction ban was still on because PM2.5 decreased, but not to a level that was considered suitable for construction activities to resume. So with this whole ecosystem, we are really empowering decision makers. The decision-making activity has significantly been enhanced, but there are still some challenges, especially around when the air quality changes, jumps from one category to another. So in those events, even a 2% error into air quality forecast can affect the ability of decision makers in imposing appropriate restrictions. But so far, this has been helping. We work closely with Commission for Air Quality Management to brainstorm ideas on further improving the accuracy of the system. So with this, I will leave the summary slide up and thank you and take any questions.
Thank you, Rajesh, for your insightful presentation. Really give us more insights on how Delhi can deal with high pollution event. Before I go to Q&A session, I would like to offer this session actually to Aska. Aska, would you like to continue this session with Q&A
Hello,
session?
Fadil.
Yeah,
Can
I
you
can
hear
hear
me?
you now. Yes.
Okay, finally. Sorry, there was a trouble with my laptop. But yeah, hello everyone. Sorry. Before that, let me introduce myself first. I'm Azka, Air Quality and Climate Research Analyst for WRI Indonesia. And for today's session, we already on the Q&A session. So for those of you who already have a question, please type your question on the Q&A section. You can type it on Bahasa Indonesia or in English. And I think we already have a question. I will read the question for you, Rajesh. Okay, for the first question, it's from Muti. How do you establish and develop decision support system? And can you explain more about the particular approach that you mentioned for this support system? That's the first question. Over to you, Rajesh.
Yeah, thanks, Moti, for the question. So basically, WRF-Chem is a model where we represent all the physics and chemistry-based processes, and then we provide emissions as input to the model. So what we are doing is we are tracking black carbon, organic carbon, and direct PM2.5 emissions, which actually constitute more than 90% of PM2.5 in the model. So we are tracking each of these species from Delhi and different emission sectors. So there is a tracer approach that we have developed, and I can actually share my paper that describes this approach. It's a 2015 paper in JGR with the title, What Controls the Seasonal Cycle of Black Carbon Aerosols in India. So the tracer approach is described in that paper.
Hopefully that's answered the question, yeah, Mbak Muti.
Yeah. And so Moti, please feel free to write to me. I will leave my email address in the chat, and I'm happy to talk to you more about it if it is not clear to you.
Okay, thank you so much, Rajesh. I think we already have another question. Oh, wait a second.
Yeah, I can read it.
You can read it? Okay.
This is from Imas, and Imas is asking why do I use WRF-Chem instead of high split? So Imas, as you know, that high split treats air masses as inert. So you can actually follow the transport of air mass, but how much chemistry is happening into that air mass, how emissions are being added to that air mass, how much deposition is happening in an air mass, those processes are not represented into a high split model. In the WRF-Chem model, we represent all these processes using physical and chemical parameterizations. So WRF-Chem is much more advanced compared to a high split type of model. So the time series prediction algorithm, we are not using a time series prediction algorithm. We are actually running WRF-Chem, which is a 3-dimensional model, into the forecast mode to generate the time series. I hope that answers your question, but please feel free to be in touch with me if you need to. Then there is an anonymous question saying that how could you differentiate the pollutant source, such as transportation, industrial, etc.? What is the error rate of differentiating the source? This is quite important to avoid misleading information and to provide accurate steps for policymaker. I absolutely agree that any error could be misleading for the decision makers. But when we develop the emission inventory, we keep all the emission sectors separate. So we know how much emissions are coming from the transport sector, industry sector, energy generation sector. So this is a an emission inventory that is generated by Indian scientists through collections of activity data, emission factors that are measured in India. So there is still scope of having some errors into those estimates, but these are the best estimates that we have as of now. So our emission inventory actually includes that granularity that we need to track different emission sources. So then, okay, thanks, Muti. How does...
I think there's a question in Bahasa Indonesia, Rajesh. I will translate it to you. It's from Irwansyah. Irwansyah asked about, can you explain more about how flow from the from the data when the air pollution high, and then how the government decide to okay, we have to stop this activity to prevent the higher pollution.
Yeah,
that's it.
So it depends on the graded response action plan. So let me share my screen again. So the government looks at the level of PM 2.5. And so here, if we go back to this slide, then if say, for example, PM 2.5 is more than 300 micrograms per meter cube, and PM10 is more than 500 micrograms per meter cube, then the action to take is stop truck traffic entry in Delhi, stop construction activities, introduce odd even scheme, and potential school closure. So the government has predefined the actions corresponding to the predicted level of PM 2.5. All right, so then there is this question about the interagencies within government coordinate when it comes to the peak event. So that responsibility lies with the Commission for Air Quality Management. It is the overarching body that controls all different components of regulatory bodies, and it directs different bodies to work together. So the decision from the CAQM, the Commission for Air Quality Management, has the highest priority. So the coordination is actually done by the CAQM. There is a question from Rizki. Since Indonesia is an island country, we need more effort to do as same as this is due to every location or island had special sources. How government and academia collaborate in order to plan and do the progress in air quality management in India. So very interesting question, Rizki. So basically, the Indian Institute of Tropical Meteorology, it's more of an academic research institution helping the government, and they very closely work with the India Meteorological Department. So I believe Indonesia also have a national meteorology services. So there needs to be collaboration between the academic community and the Indonesia Meteorological Services to develop this type of projects. So in India, the Ministry of Earth Sciences, which oversees the India Meteorological Department, as well as Indian Institute of Tropical Meteorology, also provides funding to the university community in India to work on these systems. So Indonesia, I believe there is a similar system may exist. If not, that is one of the things that can potentially be done. Yeah, thank you,
sorry.
Iman. Yep, go ahead.
Yeah, so just I think there's an unanswered question that you can answer by email or respond it by email, since we have a limited time for the session. Is that okay?
Yeah, that sounds good. I'll put my email in the chat. So anyone, if you want to reach out, please send me an email.
Okay. Thank you so much, Rajesh, for your presentation and for your answer for this Q&A session. And now we will move to our second session. We will have a panel session with our city representative. We have from Jakarta and Manila City. Can you give a spotlight to our speaker? So, yeah, we already have Ibu Rahmawati here and Mr. Jundy. Is Mr. Jundy already here? Yes, Mr. Jundy. Oh, you're on the attendees. Can you join? Can the operator help me to allow talk to Mr. Jundy? Okay. First of all, I will little bit give an introduction about our speaker today. I have the two speakers. The first one is Mr. Jundy. Okay, Mr. Jundy is a supervising environmental management specialist for Environmental Management Bureau Central of Manila. He is currently serving 23 years in the government service at the Department of Environment and Natural Resources, Environmental Management Bureau, and he is currently holding the position of Chief Air Quality Management Section as Supervising Environmental Management Specialist. Welcome, Mr. Jundi. Thank you for joining us today. And
Hello.
for the thank you. For the second panelist, we have Ibu Rahmawati. Ibu Rahmawati is Head of Environmental Subdivision from the Jakarta Environmental Agency atau Dinas Lingkungan Hidup Jakarta. Ibu Rahmawati has been serving with Jakarta Environmental Agency for 21 years and is currently in the role of Head of Environmental Monitoring Subdivision at the DKI Jakarta Environmental Agency since March 2021. Before her current position, she held significant roles in the subdivision of waste management and air pollution monitoring starting in 2015. She has participated in various environmental management training programs, including those focused on waste management, emission inventory, and development of strategies and action plans for enhancing urban air quality. For the first panelist, we already prepared the question for you to answer. And you can answer by present your presentation, or you can directly answer the question. I think we already share with you about the how is current air quality in Manila and what source main source of the air pollution in Manila. And the second question about the how the government better collaborate with technology companies and research institutions to harness data and tools for more effective pollution, and share with us an example of successful case study where data-driven approach have played a crucial role in reducing pollution levels and improving urban air quality. So for Mr. Jundy, whenever you're ready, please go ahead and start your session.
Okay, can I share my presentation?
Yes, please.
Okay, can you see my presentation? Hello?
Yes. Yeah, we can hear. We can see it.
Okay, so I'm Jundy Del Socorro. I'm from the Environmental Management Bureau of the Department of Environment and Natural Resources in the Philippines. So I'll be answering 3 questions. One is the current conditions of Manila, and when it's usually the peak of air pollution in Manila, and what are the major sources of Metro Manila. So I'll be explaining not only Manila, but the entire country. Okay. So first, I'll just need like to inform you about the air quality network of the Philippines. Right now, we have 137, and 118 are maintained by the government, and the others are 10 new stations for 2023, and 9 adopted stations are coming from partnership from government agencies. So we still use manual monitoring, the ones that are still requires analysis for the laboratory, like filters for weighing the mass of the filters, and also the absorbing solutions for gases. But for conventional stations, we have, continuous monitoring stations. We have UV, chemiluminescence, and DIR, BOM, light scattering, and TEOM, and also the open path monitoring.
Mr. Jundy, sorry to interrupt, but can you share a full screen? Full slideshow in full mode, yeah.
Yeah, wait.
You can unshare first and then present again and click the slideshow. Yes. Thank you, Mr. Jundy.
Okay, pull slide please. Okay. So these are the manual monitoring that we are still using right now. This gravimetric samplers. Then also the continuous conventional monitoring stations. We use UV ultraviolet analyzers for SO2, chemiluminescence for NO2, and non-dispersive red for carbon monoxide. Also, the tapered element oscillation microbalance or the TEOM for PM10 and PM2.5. The OpenFAT, it's a UV analyzer. We are capable of monitoring SO2, NO2, ozone, and three VOCs such as benzene, toluene, and xylene, and non-dispersive infrared for CO again. So for the entire country and the Manila, so since the enactment of the Philippine Cleaner Act, we have we still monitor total suspended particulates because we still encounter a lot of course particles in our country. That's why we still maintain this one. We have slightly higher pollutants in the early 2000, but due to policies such as the including 2% biodiesel and bioethanol in our fuels, and also improving from Euro 4, Euro 2 to Euro 4 standards, policies on SO2 on industrial sources, establishing real-time connection on emissions monitoring on the industrial sources, such as those firms with SEMS and COMS, and other industrial policies such as the correction of oxygen in the emissions of industrial sources. We have observed some slight improvement by 42% since 2002 up to currently the first quarter of this year. But you can observe during the pandemic there's a significant decrease because, of course, of the recent halt of activities during the COVID pandemic. And for Manila, it's around 47% decrease, but now it's fastly going back again after the pandemic. So in terms of finer particles, yeah, we also observe significant improvement through policies on fuels and motor vehicles. By the way, the major source of air pollutants in the Philippines, later I'll be discussing, is still the transport sector or the mobile source as compared from stationary to mobile. So some policies, especially on fuels or motor vehicles, we believe that has a significant impact and improvement of PM10 results, and also such as the reduction of sulfur content from Euro 2 to Euro 4 from 500 parts per million to 50 parts per million right now. And all of those, what I've mentioned, other industrial source policies. So by the way, we started initiating the Euro 4 emission standards by 2016, and I think we believe that there are improvements from 2016, and of course during the pandemic, and right now we're maintaining the levels up to 27, 26 micrograms per normal cubic meter per PM10. For finer particles such as PM2.5, yeah, in since 2015, there have been a very slight improvement, and up to the pandemic. But we have before the pandemic, there's really some increase, and right now, from 2020 to 2020, first quarter 2023, we're slowly going back, or I mean increasing the levels of PM2.5 due to the starting of the economy since what happened during the pandemic. But overall, from 2015, we have 22% improvement nationwide and 30% improvement for Manila. So we also experience some seasonal problems here in Manila and other parts of Philippines. But in recently, just recent weeks, we experience both combination of the urban traffic and at the same time a temperature inversion in which the hotter temperature stays up a colder temperature in the surface, prompting gases and particles not to be dispersed vertically. So there's some increase in PM10. That's why we have cautioned the public not to go out, especially if there's if they have underlying health problems. In terms of PM2.5, during the recent week, I think it happened September 7, September 9, and just September 21 last week was the most worst during temperature inversion cases in the Philippines. We checked the soundings of our meteorological stations or the nearest radio zoned stations in Manila, and we've seen some inversion and very weak or very calm wind that does not help in the ventilation of the air pollutants. That's why we have some problems with visibility or haziness in Metro Manila recently. But thank God it rained after this event. It rained so hard, that's why it was washed out. For the emission inventory, so it's consistent. We are doing every 3 years of inventory since 2002, and it's been consistent. You can see the orange is the stationary resources, and the blue, lighter blue is the mobile source, and the darker blue is the stationary source or the industries. And still, one of the major sources of air pollutants in Manila is, in the Philippines and Manila is the transport sector or the mobile sources. And in the recent, which is not yet official because we're still having data gathering, and for 2021, again, still the mobile source at 60%, which is the current source of air pollutants in the Metro Manila and the Philippines. So that's for the first question on the status of air quality and the sources of air pollution in the Philippines. The second question is the increasing concern, considering the increasing concerns about air pollution in cities, how can government better collaborate with technology companies and research institutions to harness data and tools for more effective pollution management and public communication during high pollution episodes? So we have collaborations, partnership with private sectors. Again, as I've mentioned, we have this adapt and ambient air quality monitors, because in the Philippines we utilize, follow US EPA reference or equivalent methods, or those regulatory grade equipment, which is quite expensive. So we have this partnership project, so we could expand our network, and this partnership are through the industrial and commercial sector that are willing to help the government monitor air quality and share the data in the Philippine Air Quality Monitoring Network. So that's through partnership, and also we also engage in collaboration with technology companies, so we could help improve our internet-based platforms such as our website, our social media sites, and coming up with different ways in reporting air quality, such as real-time platforms available in both in our cell phones using iOS and Android, and also platforms using Microsoft Power BI and all those internet-based IT platforms that we are in collaboration with. Another thing is partnership with the industrial sector, in especially those with continuous emissions monitoring system, like power plants, cement plants, refineries, and through partnership with them and our IT companies, we are able to establish data centers in the entire country, and it's connected in our central office here in Manila. So for information, the Philippines is subdivided into 16 regions. So we are an island nation, and all of those islands has different sources of industrial sources with continuous emissions monitoring system. So every regions has their own data center connected to the SEMS and COMS in real time. And this is connected to the central office here in Manila. So we could see what's the real-time monitoring in terms of particulates and gases like PM, CO, NOx, and SOx. So this is what our data center looks like, and each regional office has this data center. And we will not be able to establish this one without the partnership with the private sector. Another partnership is with the research institution, because in the Philippine Clean Air Act, we have only criteria pollutants in the ambient air quality guideline values such as TSP, PM10, PM2.5, carbon monoxide, carbon dioxide, nitrogen oxide, ozone, and lead. But through partnership with research institutions and our university, we have an ongoing study on coming up with additional ambient air pollutants in a project called the Hazardous Ambient Air Pollutant Project. So through this one, we will be eyeing additional parameters such a long list of heavy metals from cadmium, mercury, chromium, and all of new at least 8 to 12 heavy metals. We are also eyeing to come up with guideline values for ambient dioxin effluents, also for ambient polyaromatic hydrocarbons, total VOC, and hydrogen sulfide, and black carbon. So in the in the past decades, we have a lot of spent filters, and through apportionment and partnership with the research institution, we're able to extract or do apportionment with the spent filters from our air quality network. And the data gathered here aids us in coming up with additional ambient air quality pollutants through the HAZA project. And these are the apportioned of how we analyzed our spent filters. And we, through a partnership also with the intergovernment agencies for environmental health, we have gathered data from in different Philippine hospitals and medical institution, medical organization, in correlating the levels of, this is just one example, PM10, and we're doing it to also the same, we're replicating the same to all those pollutants included in the HAZA project, and we're correlating this one to the hospital cases from COPD, cancer, hospital admission, and determining the risk of air pollutants. I mean, the risk of exposure of the public to air pollutants. And from here, we are able to come up with the methodology in determining the air quality index breakpoints. So this is also part in the formulation of the air quality guideline values, because air quality guideline values should have a corresponding breakpoints for us to quantify also its air quality index. Those are some of the collaboration. Now, here are some successful case studies so far that were data-driven approaches.
Mr. Jundy, you have
Yeah.
1 minute left for your presentation.
Yeah, I'm about to finish. So during the partnership or establishment of the data center, the aim of this one is to come up with the data and in reviewing our stationary sources or industrial sources emission standards. And right now, the data is collected here are being statistically analyzed, so we could tighten our stationary industrial source emission standards. But even if it's still undergoing review and we have not yet published a tightened air quality standard, we have seen a self-regulating effect in our industrial sources. Like it's from 50 to 80% decrease, reduction from their emission, because we are have access in real time in their emissions. So from SOx, NOx, so PM and CO, we have seen like 50 to 80% reduction, or we call this the self-regulating effect, as if we have revised a tightened emission standards for industrial sources. So again, also one probably success case studies is the reduction in PM10 levels and PM2.5 levels when we reduce the sulfur content in our fuels by 90% from 500 ppm to 50 ppm, and hopefully in the coming 3 years we'll be reducing another 80%. We're eyeing up to Euro 5 or Euro 6, okay, by 2027. So that ends my presentation, and you can visit our website for all the platforms, online platforms related to air quality monitoring and permitting in the Philippines. Thank you very much, and thank you for listening.
Thank you so much, Mr. Jundy, for your presentation. And now we will move forward to our second panelist. We already have Ibu Rahmawati or Ibu Wei. Ibu Wei here today will provide us with a valuable insight into Jakarta air quality, and she will share with us about the Jakarta air quality and how government mitigate high pollution episodes that currently occur in Jakarta, and what kind of strategies or platform that the government employ to actively involve and inform the public in pollution monitoring and mitigation effort. Without further ado, Ibu Wei, silakan dimulai presentasinya. Can you, the operator can share the slide for Ibu Rahmawati? Or Fadil maybe?
Terima kasih Mbak Aska. Mohon maaf, saya menggunakan bahasa Indonesia untuk presentasi ini. Terima kasih kepada WRI Indonesia dan juga WRI Global yang sudah menyelenggarakan acara pada siang hari ini, dan alhamdulillah juga sudah mendengarkan tadi dari Delhi ya dan Manila apa-apa yang sudah dilakukan sama di kota Delhi maupun Manila. Jadi juga banyak mendapat insight terkait dengan kualitas udara. Next. Ya, oke. Jadi kalau kita berbicara terkait kualitas udara Jakarta, saat ini sudah berapa ya, 2 bulan, 3 bulan terakhir ini pencemaran udara merupakan isu yang paling dominan di media-media, menyampaikan bahwa Jakarta itu paling polusi di antara negara-negara di dunia ya, hal itu ditampilkan oleh beberapa aplikasi yang memang membuat ranking kota-kota di seluruh Indonesia. Nah, sebetulnya seperti apa sih kualitas udara di Jakarta, terutama untuk PM2,5 ya. Kenapa PM2,5? Karena memang itu yang menjadi parameter kritis untuk air quality index ya di Jakarta, sehingga PM2,5 yang coba kita sampaikan seperti apa nilainya gitu ya. Nah, untuk nilai PM2,5 konsentrasinya rata-rata tahunan ini terlihat sekali bahwa sebetulnya secara tren itu ada penurunan ya sebetulnya dari tahun 2019 sampai dengan 2022 tahun kemarin. Karena memang 2020, 2021, 2022 itu pasca COVID dan COVID itu kalau dari lihat rata-rata dibandingkan 2019, kita baru mengukur PM2,5 itu pada tahun 2019. Itu rata-rata sejakarta itu 48,27 mikrogram per meter kubik, dan pada tahun 2022 itu 37,33 meter kubik. Nah, ini kecenderungannya memang turun. Kita belum tahu tahun ini seperti apa. Rasanya sih agak naik kembali ya rata-rata tahunan di DKI Jakarta, karena tahun ini sudah mulai lebih aktif aktivitas yang ada di pembangunan dan lain sebagainya lebih aktif dibandingkan tahun-tahun sebelumnya. Next, Mbak Aska. Kemudian ini adalah sebetulnya Jakarta memiliki stasiun pemantau yang reference method itu ada 5 stasiun, ya ada di Bondoran HI, Kelapa Gading, Jakarta, Lubang Buaya, dan Kebun Jeruk. Sementara selain pemerintah Provinsi DKI Jakarta, BMKG atau Badan Meteorologi, Klimatologi dan Geofisika itu juga punya stasiun pemantau 1. Kemudian ada juga dari US Embassy itu ada 2, dan dari Kementerian Lingkungan Hidup ada 1. Jadi totalnya ada 9 sebetulnya stasiun reference yang ada di DKI Jakarta, di mana kita mengukurnya untuk di DKI Jakarta kita mengukur ada 6 parameter atau 7 ya, dengan hidrokarbon, ada PM10, PM2,5, CO, ozon, SO2, dan NO2. Sementara BMKG, US Embassy itu hanya 1, PM2,5, dan KLHK itu seperti kita, Pemda DKI itu ada PM10, PM2,5, CO, ozon, SO2, dan NO2. Selain itu kita juga mengukur meteorologi seperti wind speed, wind direction, humidity, solar radiasi, dan juga curah hujan. Ini semua kita bisa lihat di platform kita ya. Kemudian untuk melengkapi ini ya, pada tahun ini juga kami sudah diberikan ya, kami juga difasilitasi untuk melengkapi parameter yang ada. Kami oleh WRI Indonesia itu dilengkapi ada parameter black carbon yang tadi sepertinya di Manila dan Delhi sudah melakukan itu, sementara kita baru dari WRI ini, dan saat ini juga masih commissioning ya kondisinya black carbon yang diletakkan pada 4 stasiun. Kemudian kita juga dapat tambahan dari WRI PM2,5 itu sebanyak 3 stasiun ya. Mudah-mudahan ini juga bisa melengkapi secara keseluruhan representatif stasiun pemantau kualitas udara yang ada di DKI Jakarta. Selain itu kita juga mendapatkan local sensor yang dari kolaborator itu sebanyak 14 alat dan ini juga masih dalam taraf settlement ya, jadi belum kita publish juga datanya, namun kita masih melihat sebetulnya penggunaan loco sensor di Jakarta seperti apa. Next. Kemudian tadi Manila dan Delhi juga menyampaikan terkait dengan emission inventory. Ini Jakarta juga kami terakhir itu pada tahun 2020 melakukan emission inventory di Jakarta, di mana sumber pencemar utama itu memang hampir semua parameter ya kecuali SO2 itu berasal dari kendaraan bermotor. Paling tinggi di sini untuk PM, untuk black carbon, untuk non metal volatile organic compound itu dari kendaraan bermotor sebesar 98%, sementara PM2,5 67%, black carbon juga cukup tinggi, dan CO ya. Selebihnya di atas 50% itu memang semua parameter kecuali SO2 itu berasal dari kendaraan bermotor. Hanya SO2 saja yang berasal dari manufaktur ya, dari sektor industri. Ini mudah-mudahan dengan adanya emission inventory ini segala sesuatu terkait dengan kebijakan, strategi untuk menurunkan ini bisa kita lakukan agar emisinya bisa berkurang. Next. Oke, kalau tadi kita berbicara sampai dengan tahun 2022 terkait dengan PM2,5. Nah, sebetulnya tadi yang saya sampaikan, kita di Jakarta punya 5 stasiun pemantau ya. Kemudian seperti apa rata-rata bulanannya dari tahun ini dan tahun kemarin, tapi kita lihatnya secara bulanan gitu ya. Di sini terlihat sekali bahwa mulai bulan Mei hingga Agustus ya, itu kecenderungan PM2,5 kita memang mengalami peningkatan akibat musim kemarau. Jadi dengan musim kemarau ini memperparah kondisi kualitas udara kita, terutama parameter PM2,5 itu dari trennya memang terlihat meningkat. Kita lihat kalau misalnya di 2023 ini yang warna biru itu terlihat sekali peningkatannya mulai dari April ya, dari 29,75 menjadi 47,44 di bulan Mei ya, yang memang paling tinggi-tingginya musim kemarau tersebut. Next. Oke. Kalau kita bandingkan antara musim hujan dan musim kemarau, itu terlihat sekali bahwa di musim hujan nilai PM2,5 kita itu masih hijau, di mana ini masih sekitaran paling tinggi itu 30 mikrogram per meter kubik ya. Namun ketika bulan Agustus itu nilai kita sudah di atas 55 mikrogram per meter kubik. Ini memang terlihat sekali jauh perbedaan nilai rata-ratanya di setiap lokasi yang kita miliki, menunjukkan bahwa ketika musim kemarau pengaruh terhadap parameter PM2,5 ini menjadi signifikan. Next. Nah, ini adalah indeks standar pencemar udara yang dimiliki di Indonesia, di mana kami memiliki standar atau panduan untuk menghitung indeks pencemar udara berdasarkan Peraturan Menteri Lingkungan Hidup nomor 14 tahun 2020 tentang indeks standar pencemar udara. Nah, kalau kita bandingkan sebetulnya antara Indonesia dengan WHO di Indonesia dengan PP 22 tahun 2021 ini masih pakai PP yang lama ya, belum diganti. Jadi di PP 22 tahun 2021 itu sebetulnya PM 2,5 itu rata-rata hariannya adalah 55. Sementara di WHO ini sebesar 15 ya. Ini juga mungkin masih yang ini ya, Mbak Aska ya. Kemudian untuk kriteria atau apa ya, nilai untuk meranking indeksnya tersebut sebetulnya antara Indonesia dengan US EPA itu mirip-mirip ya. Hanya saja kita di Indonesia itu tidak ada angka untuk orang-orang yang punya kebutuhan khusus begitu ya. Kita semuanya disamaratakan begitu. Jadi ketika 0 sampai 50 itu baik, itu sama juga dengan USIPF. Kemudian 51 sampai 100 itu adalah sedang. Kemudian nah ini kalau kita di 101 sampai 200 itu kita adalah tidak sehat. Selebihnya 201 sampai ke atas itu sangat tidak sehat dan berbahaya gitu ya. Tapi kalau di US EPA itu mereka membagi dua kelompok ya, dari tidak sehat, kemudian sangat tidak sehat, kemudian berbahaya. Jadi memang terakhir dengan standar pencemar kita yang terbaru pada tahun 2020 ini kita tidak membedakan dari Kementerian Lingkungan Hidup tidak membedakan antara kelompok tertentu dengan masyarakat secara keseluruhan. Next. Ini adalah hasil indeks kita pada tahun 2023. Ini terlihat sekali di mana Januari sampai dengan Agustus itu hari dengan kategori baiknya itu bulan Januari, Februari, Maret ini masih ada hari baiknya, sementara Agustus itu terlihat makin tidak ada dan makin banyak hari dengan kategori tidak sehatnya. Jadi kalau di bulan Agustus itu dengan 31 hari, 27 harinya itu di Jakarta itu tidak sehat. Hanya 4 hari saja yang berkategori sedang gitu ya. Jadi ini menunjukkan bahwa memang kondisi pencemaran di Jakarta atau kualitas udara di Jakarta bukan dalam kondisi yang baik-baik saja. Memang hari dengan kategori tidak sehatnya sudah lebih dari 20 hari. Next. Oke, kemudian apa yang kita lakukan dengan kondisi yang semakin parah gitu ya, semakin kualitas udaranya semakin menurun. Pada tanggal 29 Agustus tahun 2023 kemarin, Gubernur telah menetapkan keputusan Gubernur nomor 567 ya, maaf, 576 ya, tahun 2023 tentang strategi pengendalian pencemaran udara, di mana di dalamnya itu ada 3 strategi, kemudian ada 68 aksi yang memang diperuntukkan. Aksi ini dilakukan oleh semua unit di bawah Gubernur Provinsi DKI Jakarta untuk melakukan aksi-aksi penurunan kualitas udara sesuai dengan sesuai dengan tugasnya. Misalnya di Dinas Lingkungan Hidup begitu ya, bagaimana kita harus melakukan pemantauan dan kualitas udara ini lebih representatif, maka kita harus menambah jumlah stasiun pemantau kualitas udara agar lebih representatif. Itu yang harus kita lakukan aksi di DLH. Kemudian yang kedua, apalagi misalnya uji emisi kendaraan bermotor, terutama untuk private car ya, untuk kendaraan pribadi. Maka kami menggalakkan, kami membuat bengkel-bengkel uji emisi yang tersertifikasi, kompetensi personil bengkel-bengkel untuk bisa melakukan itu, dan kami memperbanyak sosialisasi uji emisi gratis kepada masyarakat agar semua masyarakat itu mau melakukan uji emisi untuk perbaikan kualitas udara di Jakarta. Contoh lain adalah misalnya Dinas Perhubungan itu harus melakukan penambahan jumlah armada yang lebih ramah lingkungan, menambah rute kendaraan, kemudian menambah pedestrian, menambah ruang untuk bisa membuat masyarakat itu melakukan aktivitasnya dengan moda transportasi yang lebih ramah lingkungan. Itu merupakan bagian dari kewajiban yang harus dilakukan oleh Dinas Perhubungan. Dan yang lainnya juga demikian. Jadi seluruh institusi di DKI Jakarta harus melakukan aksi menurunkan kualitas udara di DKI Jakarta sampai dengan 2030. Next.
Bu Wei, maaf mengingatkan waktunya 2 menit lagi ya, Bu.
Oke. Oh, tadi nggak ada ininya ya, sebentar. Oke. Jadi tadi di SPPU tadi kita ada target untuk menurunkan emisi PM2,5 sebesar 41% pada tahun 2030 ya. Kemudian karena tadi saya sampaikan bahwa kualitas udara kita semakin buruk pada periode Mei ke September, ini kita melakukan quick response yang dimana semua gedung-gedung bertingkat diminta untuk memasang mist spray gitu ya, mist generator yang dilakukan di atap-atap gedung ya untuk penurunan kualitas udara. Next. Ini contoh. Kemudian ini mist generator yang kita pasang di kantor gubernur. Di sini terlihat bahwa memang ketika dipasang mist generator itu terdapat penurunan PM2,5 dan peningkatan kualitas udara pada saat kurang lebih setelah penyemprotan itu terlihat bahwa memang pengoperasian water mist ini sungguh efektif untuk menurunkan PM2,5 dan meningkatkan kualitas udara yang ada di sana. Next. Ini juga ya perbandingan tadi hasil dari pengoperasian water mist yang ada. Next. Kemudian sebetulnya apa yang dibutuhkan atau sebetulnya masyarakat bisa melakukan apa gitu ya. Jadi kita mencoba untuk ini ada kajian dari Vital Strategis yang mencoba melihat sebetulnya dari strategi-strategi yang ada di Jakarta sesuai dengan strategi pengendalian pencemaran udara tadi, strategi mana yang paling efektif untuk menurunkan. Jadi sebetulnya di sini ada OTR 4 dan OTR 5 yang lebih tinggi, lebih signifikan untuk menurunkan emisi PM2,5. Ini kalau kita lihat di OTR 4 itu adalah uji emisi secara berkala dan OTR 5 adalah peralihan ke angkutan umum. Jadi dibandingkan aksi-aksi lain ya, pengadaan KDO yang vehicle yang listrik ya, kemudian pengetatan standar emisi hingga pelarangan pembakaran sampah gitu ya. Ini yang paling efektif lebih tinggi untuk mengurangi emisi adalah ini OTR 4 dan OTR 5 ya. Jadi next. Kemudian ini platform ya yang disampaikan oleh kami. Kami di Dinas Lingkungan Hidup ada 2 platform sebetulnya, ada di Jakarta Smart City dengan Jakinya dan juga di website kami di Dinas Lingkungan Hidup ya. Dengan memang di sini tampilannya adalah masih 5 lokasi yang kita miliki. Nanti mudah-mudahan dengan adanya platform peralatan dari WRI ya, karbon dan PM2,5, kita bisa menambah ini jumlah titik yang terinformasikan kepada masyarakat. Next, itu ya terakhir. Baik, itu saja yang bisa saya sampaikan. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Terima kasih Ibu Wei atas penyampaiannya. For those of you who already have a question, you can put the question on our Q&A feature. Or do we still have the time? Or maybe from our other panelists who have a response, or you have a insight for each other panelist, maybe you can also open mic. Is there any panelists or from the participant who wants to ask question or respond our the presentation? I think Rizky Andre, you have a question to DKI Jakarta government, but the question is not ready yet. Wait, ya, tunggu Bu Wei, masih diketik kayaknya Bu. I think I will give a first question. Maybe I can ask the question to Mr. Jundy. Really interesting about actually in Manila, the air quality throughout the year mostly in a good condition, but also sometimes Manila also facing the bad air quality. From Delhi and Jakarta, they have a quick response mitigation. And how about in Manila? Is Manila also have a quick response, or how Manila give a mitigate the air quality when it's going to high in some period? To Mr. Jundy.
Well, in the Philippines, we have this national risk reduction council, wherein we have these intergovernmental members from our meteorological office, from the military, from other government Department of Health. If there are disaster risk related incidents such as volcanic eruption, earthquakes, floods, and including haze or air quality problems, just like what happened last week. So we have this, just like in Indonesia, we have this air quality index with the precautionary statements that informs the local government units to disseminate or to inform their public not to go out if you have underlying medical conditions during this kind of situation. Like last week, when we have experienced this one, most government agencies, they cut all schools and all offices before 12 noon. They sent everyone else home so that if the air pollution problem still persist, then at least everyone is in their home already, so they will not be exposed to the air pollutants. So it's quite fast because at least before 12 noon, we have informed the entire public and sent most of the students and offices at home. Thank you.
Thank you for the answer, Mr. Jundy. And we have a question for Ibu Rahmawati. Ibu Wei, apakah ada tim kerja khusus dalam upaya pengelolaan kualitas udara, di mana di dalamnya terdiri dari anggota-anggota seperti pemerintah, swasta, dan akademisi? Karena saya pikir itu juga terobosan yang dapat memberikan rekomendasi-rekomendasi dalam langkah selanjutnya terkait program Air Quality Management. Silakan Ibu Wei.
Ya, terima kasih. Jadi memang tadi di strategi pengendalian pencemaran udara sebetulnya di bagian akhir dari keputusan itu ada bukan satgas ya, ada kelompok juga ya yang memang di sana diketuain sama asisten pembangunan ya kalau salah, dan SKPD terkait. Namun tadi ya untuk NGO ataupun komunitas begitu apakah masuk karena di dalam keputusan gubernur itu sifatnya ke dalam gitu ya, mengatur ke dalam, maka pelaksana di dalam kelompok atau satuan tugas tersebut adalah di pemerintah. Namun demikian kita tidak menutup kemungkinan karena kita ada yang namanya KSBB KSBB. Jadi KSBB skala besar gitu, kolaborasi skala besar, di mana udara merupakan salah satu substansi yang memang kita gadang untuk kita kuatkan berkolaborasi dengan komunitas. Jadi selain memang di dalam satuan tugas yang memang ada keputusannya gubernur, ini sebetulnya kita juga ada program kolaborasi skala besar di mana salah satunya adalah materinya adalah udara. Jadi bukan tidak memungkinkan untuk kita sama-sama mendukung untuk mengurangi pencemaran udara di Jakarta.
Oke, baik Bu Wei. Ada pertanyaan selanjutnya Bu. Ini dari Ananda Putri menanyakan tentang kira-kira apakah sudah ada target lokasi untuk titik penambahan stasiun kualitas udara di Jakarta?
Iya, sudah ada. Jadi hasil terakhir kami tahun ini kita membuat kajian ya, membuat telaan sebetulnya seberapa banyak jumlah stasiun yang memang representatif untuk kita lakukan pengukuran. Ini sebetulnya sudah ada di atas 25 ya, 27 lokasi termasuk di Pulau Seribu. Itu kalau secara reference dengan menggunakan metode referensi itu kita harus miliki stasiun dengan jumlah 27 stasiun gitu. Selebihnya kita bisa gunakan metode yang di bawahnya begitu ya, indikatif seperti LCS mungkin lebih banyak lebih baik begitu ya untuk karena memang sifatnya lokal.
Oke, baik Ibu Wei. Masih ada satu pertanyaan Bu terakhir mungkin ini. Jakarta memiliki aplikasi Jaki. Apakah kualitas udara yang secara real bisa dipantau warga melalui Jaki? Apabila belum, apakah akan dikembangkan ke sana? Silakan Bu.
Di Jaki itu sebetulnya sesuai dengan peraturan Menteri Lingkungan Hidup nomor 14 tadi ya, tahun 2020 tentang ISPU. Jadi memang harus ditampilkan 1 jam sekali. Jadi setiap jam itu angkanya akan berubah di setiap titik yang kita punya sekarang 5 itu, setiap jam pasti berubah. Tapi memang kalau yang di Jaki itu tidak bisa di-download, hanya bisa dilihat sebetulnya indeks standar pencemar udara pada jam tersebut. Kalau sekarang ini jam 10 ya, itu pasti ketika kita buka Jaki nanti di sana ada lainnya, nanti ada kualitas udara, kita klik itu kita bisa lihat kalau sekarang 10.56 maka jam 10 itu sudah terpantau berapa kualitas udara dengan ISPU itu pada jam 10 itu. Jadi itu yang kita bilang real time. Jadi pada jam segini nanti jam 11 lewat sedikit, mungkin 11 lewat 10 itu udah keluar lagi jam angka indeks yang jam 11.
Jadi udah bisa ya Bu dijaki sekarang.
Ya, dan website kita ya. Website kita juga secara online.
Oke, terima kasih untuk Bu Wei, and thank you for Mr. Jundy for this sharing session. I think we are have done with our session. So once again, thank you for all joining us today, and I think we hope you found this session informative, and we look forward to connecting with you in our future events. I'll give back the virtual stage to our MC, Fadil. Over to you, Fadil. Thank you so much.
Thank you, Aska. Thank you for all the panelists. Bue from the LH Jakarta, Mr. Jundy from Manila, and also our main speaker, Rajesh Kumar, and also Beatrice and Mas Tommy to also participate in this session.